So as we move in a little bit further into apportionment, besides the Hamilton method, we also have what's called the Jefferson method of apportionment. So this comes from Thomas Jefferson. Again, this was also in 1792. So it also uses a divisor method, but this divisor method works a little bit differently. So again, the goal of apportionment again is you want to use the total population of the groups, and you want to make sure you apportion each group based on population. And again, you have a fixed number of seats to distribute. As we were saying, there's 435 seats in Congress. And again, in the Senate, we have 100 seats. But the Senate does not use apportionment because the Senate, each state gets exactly two representatives, two senators. But Congress is based on population. And again, the goal is we want to distribute fairly based on population. So some of the key ideals of the Jefferson method, again, is we also are looking for this standard divisor like we did in the Hamilton method. So again, it's the total population divided by the total number of seats. So that starts out the same. We also compute each group's quota, if you will, the standard quota. So again, we do the group population divided by the standard divisor. Now, this is where it gets a little bit different. So again, we do keep the decimals in this problem as well. So we may have to use what's called a modified divisor. Jefferson's method adjusts the divisor downward until the seat total is correct. So we start with the standard divisor. We divide each population by the standard divisor, and then we round all these results down. In other words, we floor them. So we don't round up, we always round down. And then from there, we check the total number of seats allocated and see if it equals the required number of seats. If it's too small, then we lower the divisor, which is going to make the quotients larger. Okay. So the goal is to create a number that matches the allocated seats. Very rarely do we create something that's too large where we have to raise the divisor back. Usually, just lowering the divisor a little bit will help us do this. Now, when we lower the divisor, we're really just going to make an educated guess on this. So we have to keep doing this lowering of the divisor until we match the seats exactly. Again, we are lowering them each time as well. There's no rounding up. It's always this rounding down. So that's kind of an introduction into the Jefferson method. So again, Jefferson method always rounds down. Again, this is going to favor larger states slightly because the rounding down penalizes smaller states more strongly. So why the divisor is adjusted downwards? The lower the divisor, that's going to create a larger quotient, more seats. A higher divisor is going to create a smaller quotient, which means fewer seats. The goal is hit the target number of seats. You want to pick a divisor that makes the rounded down quotas add up precisely. And there's where the trick is here. This makes it more complicated because we have to keep rounding down. Hamilton method, all we have to do is do that standard divisor, pay attention to the decimals, and that's about it. So we do have a question 4 here. So I'm going to stop here and then we'll apply the Jefferson method to this question 4.